We've been doing that now since, 1989-ish, so, we're getting close to 30 years. Of course, ADEQ is responsible for the Clean Water Act in Arkansas, at least a good part of it, the water quality standards. We monitor based on ADEQ's Regulation Number 2 standards. So, Regulation 2 covers the water quality. Originally, when we started this, we wanted to see what is the health of the river, what's the health of the tributaries. But now, we're seeing some issues, and now we're thinking, okay, what's that impact on our visitors? And in 2009, we added E. coli sampling at the request of ADEQ. I'm just going to show you some numbers here, and I'm really going to go through it fast, I think. Geometric mean primary contact water. I'm not even going to word the secondary contact water because we have water-based recreation all year. We want to have a very high standard for our water. We don't always attain it, of course, but we want to have a goal that I think we can attain, hopefully, and we want to protect our visitors from waterborne illness. So a geometric mean, that's 5 samples in a 30-day period. They should be spaced out evenly, which is kind of difficult sometimes. 126 colonies of bacteria per 100 milliliters of water. Basically, you take all 5 samples. This one's got 10, this one's got 400, etc., etc. You add up the total, add it up, sum it, and divide it by 5, and that's your geometric mean, essentially. 126 colonies per 100 milliliter is, when it exceeds that, then we're out of compliance. So, Dane did an excellent job talking about the swine CAFO. I don't think I have to talk about it. I have some different numbers than she has, different sources. My numbers come from the notice of intent that CNH Hog Farm Incorporated filed when they applied for the permit. So my calculations tell me that there's like 4.2 million gallons annually of waste. This untreated waste is not, this waste is untreated. It sits in those lagoons. So there's really no aerobic activity, like a lot of sewer treatment plants, they turn that waste over real fast. They pump air, it's always churning. And there are bacteria that actually break that waste down pretty effectively. But that's proven technology. So, the untreated waste is landslide, and they tell you 630 acres in their notice of intent, but there's 2 fields that they didn't have permission to apply on that were in their permit for their application. And then there's buffers for streams. There's buffers for lots of things, roads, nearby houses. So when I ran through all the buffers, I came up with about 400 acres available. 92% of these acres are directly underlain with karst. The Boone limestone, the most cave-rich limestone in all of northern Arkansas, in the most cave-rich county in the entire state, underlies 92% of these 400 acres. 43% of the fields are in the floodplain of Big Creek and Dry Creek. And when the 5,000 acres per day, or 5,000 gallons per acre per day of feed. If the lagoons are filled, from my calculations, they would be allowed to leak almost 6,500 gallons a day. The first land application manure was December of 2013. Now, so what? Why do we care? Well, we care because we care about clean water, clean air, wildlife, fisheries, cave and karst systems, prehistoric and historic structures, and we care about these things. These people. Because without the people enjoying the river, if the river becomes too polluted for primary contact, what's the point of having it? There's been national parks deauthorized before, at least a couple I can think of. or national monuments, national park areas. We don't want that to happen in Arkansas, do we?
No.
Okay, we're concerned about public health, and you can read a lot about public health, E. coli, cryptosporidium, et cetera. Can be a big problem. We share a lot of germs with our animals. We've been around for 10,000 years or more. So we've been monitoring this E. coli essentially weekly for the last, since March of last year. That's where I want to get to. Little Capo's here, Buffalo River's here. Here's our boundary. This shows single sample grabs for E. coli. Manure application began right here from DNH. We suddenly started getting huge spikes in Big Creek this year. But even more telling, really, much less volatile data are these geometric means. Manure applications of the fields began here. Waste began filling the ponds back here, I'd say, but I don't know that for sure. This geometric mean, Big Creek for the month of April, almost 500 colonies, dropped down to just on the line in May, shot back up in June, started tapering off. But notice here, this blue line is Big Creek above, is the Buffalo River above Big Creek. The green line is the Buffalo River below Big Creek. That E. coli coming into the river pushed the Buffalo River out of compliance. We're concerned. Basically, I don't know, but basically Big Creek doubles E. coli exposure risk in the Buffalo River. 6 to 13% of the sample period. And we saw Big Creek was above the recreational contact 2 months. We're going to continue monitoring Big Creek. I don't know when we're going to get to quit. And I'll just be frank with you, this is a project that was thrust upon us. We had no choice then to monitor. I guess we could have just not monitored and said, well, let's just see what happens. You know, but we really have an obligation. So I'll answer questions later on. I'll sit at the table. If there's anything you're thinking about, I'll try to answer your questions. Thank you all very much.
In the Environmental Dynamics program. Victor completed his ME and DS in Environmental and Civil Engineering at Tennessee State University in Nashville, Tennessee. He works with the U.S. Geological Survey, Arkansas Water Science Center as a hydrologist in training. Victor is conducting research on water quality, microbial biofilms, hydrogeology, and natural and engineered contaminant remediation methods. And today he's going to present on some of his information on antibiotics.
Hi, how's everyone doing? All right. So, as I was already said, I'm Victor Rowland. I'm with the USGS and University of Arkansas. And this is some work that I'm presenting here based on a study that originated at the Tennessee Water Science Center, where we were interested in coming up with some background levels of antibiotics in the environment. So the purpose of the study for us was to look at the activity within bacterial biofilms to assess the changing water quality in the surface water and in the groundwater. And some of the questions that we had specifically, what are the effects of dissolved organic carbon? Since we know that it's associated with a bunch of hog manure, you will also see more organic carbon. So that's one thing that we want to look at and say, well, what is that going to do with the actual production or the activity within the bacterial biofilms? What are the effects of antibiotics? Specifically, antibiotic resistance. That's the major concern when you start talking about antibiotics. Are you developing antibiotic-resistant bacteria there within the watershed? Then do heavy metals actually have an impact? Can they trigger some of those antibiotic resistance mechanisms that you would see in some of these bacterial biofilms associated with antibiotics, but they're actually being triggered by heavy metals? So that's another thing that we want to look at. So antibiotics, they're used to promote the growth and to prevent disease when you have a lot of hogs concentrated in a small area. Associated with the occurrence of antibiotics is antibiotic resistance. There have been several studies that have shown that where there are antibiotics in the water, there also tends to be an increased concentration or an increased occurrence of antibiotic-resistant bacteria. So, one thing that we need to really come to terms with, and was the spearhead for this, as I've already stated, we don't know exactly how many antibiotics, the concentrations of antibiotics in the environment. So we have to start off with actually being able to identify, or to say, well, this is the baseline, this is the background level of antibiotics within groundwater or within surface water. Now, in capitals, farmers are not directly responsible for saying, this is how much of this antibiotic I use for this particular animal. Only thing that numbers that we really have to go based on are the sales and the distribution of antibiotics here in the United States. So the US FDA puts out a report, and what I'm showing here behind me is that report is showing the actual mass of antibiotics that are distributed or sold in the United States.